Hello, hello. All right. Another day, another dollar. Oh wait, that's from my testing earlier. All right. Anyways, today we'll be doing Path Sum 2. Fancy question. Same thing as the one that I did yesterday. I know I keep referring to videos that I did, um, as whatever I did yesterday, but if you go to the videos tab and you look at what the video right uploaded right before this, you'll know what it is. All right. So we're going to be doing path sum 2 just to build like a build on top of path sum, or like path sum 1 or whatever. Given the root of a binary tree and an integer target sum, return all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not node references. A root to leaf path is a path starting from the root and ending at any leaf node. A leaf node is a node with no children. All right, so same thing as we did yesterday. We just want to find a path that will give us, a valid answer. And we are going to use depth first search because that's what you have to do in order to find these paths. Without further ado, let us go. I'll be creating a helper function, so we'll be writing that before we write the answer here, because that part is, I don't know if I can say the least important part, but it's just not that, it's not the beef of like the whole solution, right? Oops, that's caps. So first we're going to define a function. We're going to call it path sum helper because, well, it's a helper function. We're going to have self because it's part of the class solution, so we have to include that. We're going to have node, which is also an optional tree node. Yeah, I'm not going to call it root because after the first node that we look at, none of it will be considered the root, so I'll call it node for less confusion's sake. Target is also going to be an int because it's also not really going to be the target sum in a sense, because it will get less and less as we move on down the path. Current path, it's a list of int just to know what nodes we've looked at so that we can build our answer if we do hit a path that sums up to whatever the target sum is. And we're going to pass in results, which is a list of ints. And this itself actually returns none because it doesn't actually return anything. So I guess in that case, we'll just leave it out. And we'll just define the function as so. And so, like every recursive, or not even just recursive, just for any problem where you do, where it's optional, where the value could be null or none in this case, you should always try to handle for that case. So if not node, in this case, it'll just mean if the node that we're looking at is currently none, then this would like negate the negation, or like this is technically a negative answer because it's none, so it's negation of that, so it'd be positive. This will end up being true, so therefore we will end up just returning there. We're going to calculate a current value, which is equal to target minus node.value, because now we know there is a node, so we can access node.value. Target minus that gives us our current value. Our current path, we can dot append node.value because now we know we've accessed that node, and then we want to build our path, right? And so we're going to check if whether or not where we are so far is meeting the conditions for being a possible path sum. So we're going to do if current value is equal to 0 and not node.left and not node.right. So basically, because this is adding up, but we just subtract to see if we've gotten everything so far. If current value is equal to 0, that means we've subtracted our way all the way down, so we are equal to the target sum and not node.left and not node.right, which is the same logic used here. We want the children to be none, so that way it would be a root to leaf path. And if that is correct, we need to do result.append list and current path. The reason why we need to do list here because we want to make essentially a deep copy, and we want it to be a standalone list because current path is always going to be changing as we recurse up or like keep going down in the path. So we want, well, I mean, in this case, we'd be at a child or like a leaf node. So on the next calls, it'll just return here. So that doesn't really matter. But like, let's just say we're at 11. If for some reason, like somehow this becomes true, which it shouldn't, but let's just say hypothetically speaking right now, we need to lock in this answer in a sense. And so this will allocate memory in the runtime or whatever Python uses. It'll lock in memory for this list with whatever values we have in current path so far. Without doing this, if you were to just do current path, I guess I can show you after the solution is done, but basically you'll end up having empty lists in your solution. So once we've appended this, I think you could realistically just return here because there's nothing down there, but we'll just do it because it's, I guess, technically more efficient because you save like 2 calls and like this simple check, but does it really matter? Not really. So here we'll do path sum helper. Whoops, you need to call self here. Self.path sum helper. Node.left. What is next? Current value, current path, and the result. And then instead of doing that, we're just gonna copy paste this because you need to go down both paths, right? Left and right. And so we have that, and then we're going to do current path.pop. This is important because as you go back up, let's just say we're at 11, right? And we call this here. Actually, no, we'll do the easier one where we go all the way down to 7, right? And then so this adds up. What is our target sum here? 22. We have 9, 20, 27. 27 is not equal to that. And then it'll call these two, and then it'll end up being the nuns. So then it'll call the left one. The node.left is none, so it'll return. It'll call this one. Node.right goes down here. It's none. It'll return. And now we need to get rid of the 7 because when we go back to the 11, we stopped at this call, right? This is the call that brought us to the 7. Now we go to this call. So we needed to remove the 7 so that we can add the 2 in the next call here, which would give us the 22. Right? So we need to remove it from the list. And I guess technically you could ask why didn't you have to remove, why didn't you have to add back the target? It's because current value was passed here both times, right? And then so when you go down one path, the current value is already calculated and it's there. It's not like you have to do weird mental gymnastics to get there. They're both past the same current value down. So that doesn't really matter, right? But you just need to have this changed for the current path, just so you don't get a really random whack answer. And so now we need to build this part of the answer. So we get result equals that self.path sum helper. We pass in root, we pass in target sum, we pass in this, and then we pass in results. Results. And now we return results. And assuming we didn't completely screw this up, we should have a valid answer. Huh. Just kidding. Maybe I just don't return here. because that wasn't part of my original answer, and I'm just gonna see if that works. Okay. So that actually fixed it. Huh. Why did that fix it though? Oh, that okay. Let's see. I want to make sure. My output was this. Okay, yeah. So I actually trolled because um which answer was that one actually? Let's see. Oh, is it this one? Oh, it was this one. Okay, yeah. Um so I outputted 54845. 54845. Oh, yeah, see. Um basically, okay, so you can't return there. I guess you could do this. And then return there. Yeah, so you could do that. So the reason why you can't return is because you would skip over this and then you would end up having one extra node here, or like that doesn't have to be here. In this case, it happened to be here, right? But like it could have, you can have an extra node somewhere, and then and like an extra node from your recursion all the way back up, and then it'll screw up with your answers, like if you have any other possible paths like later on. Yeah, so yeah, actually just don't return there. Yeah, just keep that. Just keep it like this. And then it'll work. And then, yeah. Yeah, I guess I had my solution, and then I tried to be fancy with it, and I completely forgot that this had to be there. So, yeah, just don't return early. Um and yeah, just so you can see the other um thing, if I were to remove that, um your answers will end up being just empty lists, which is obviously not what you want. But yeah, so yeah, just don't, I guess, don't try to be fancy with your answers once you have one that's working. With that being said, yeah, that is all for today's video. Um, thank you for watching.